Okay, now fifth problem here. 2 electrons and a positive charge Q are held along a straight line. At what position and for what value of Q will the system will be in equilibrium? All the three charges to be in equilibrium system. All the three. There is 2 electrons and a positive charge. Right. 2 electrons and a positive charge are kept along a straight line. Therefore, 2 electrons. Okay, 2 electrons here. This is E. This is minus E. That is 2 electrons, A and B. So at this position, A and B, 2 electrons are kept, and this is the line joining. Right. Now, along a straight line, right? At what position and for what value of Q will the system will be in equilibrium? And for what value of Q? Q here it is given. The problem itself is given. See. Positive charge. Therefore, C. Where should it be? See here it is minus E. A that is minus E and B also minus E. I want to keep another that is positive charge Q. Where should it be kept so that first Q should not experience any force? Equilibrium means what is that? What is that? The equilibrium of a system. Not only for all the three charges should be in equilibrium. For that first, let us go for Q. Q has to be in equilibrium. When will Q be equilibrium? When there is net force on Q should be equal to 0. When will it be 0? Only when it is kept half the way. That is exactly, what is it? Half the way. That is at O. At O. Total distance, let it be x. Okay. Therefore, your charge Q has to be kept exactly at x by 2. At a distance x by 2 from A. Okay. The distance between E and Q is x by 2 and Q and next to that is minus E at a B. Okay. That is also equal to x by 2. Okay. Therefore, this is x by 2 and this is x by 2. Therefore, what do you say? The force, you see, force at Q due to A will be, it will be attracted now. It will be going in this direction. And due to B, once again, it is also minus E and therefore it will be going in this direction. And both the value will be the same because the charge is same, distance is same. Okay, therefore both will be equal and opposite, both the forces. Okay, force on Q due to A, charge at A and charge at B, okay, will be equal to 0. Net force. Okay, if net force on Q is a 0 means Q is in equilibrium. Okay, Q is in equilibrium. Fine. But that is not enough. The whole system has to be in equilibrium. Therefore, what? Let us consider. If A, consider this charge at A is minus E. Okay. Therefore, you can say for the charge minus E at A to be in equilibrium. If A is in equilibrium, automatically B will also be in equilibrium. So, what is the condition for A to be in equilibrium? What is that? Net force on A should be, A means what is that? Minus E is kept at A. Net force on A due to, what is the charge at O and charge at B should be equal to 0. Therefore, what is that? What is the force? Therefore, you can say, what is the force on E, okay, due to force on minus E at A due to minus E at B, that is 1 by 4 pi epsilon naught into Q1, Q2. What is Q1? Minus E, okay, and Q2 C divided by what is the distance of separation between A and B, that is equal to X square. So this is the force on the charge at A, that is electron minus E at A due to the charge at B, right? That is one more force it is experiencing, that is force at that is charge at A experiences a force due to Q also, na? Therefore, what is that? That is 1 by 4 pi epsilon naught into, what is that? Q1, Q2, Q into minus C, right? Divided, what is the distance of separation? X by 2 the whole square. This will be the total force, okay, on the charge minus E at A due to the charge minus E at B and the charge plus Q at O, okay, and but I want that to be in equilibrium, no? You should not experience any force, therefore it should be equal to 0. It should be equal to 0. Total force, okay, on minus E, charge minus E at A should be equal to 0. If it is equal to 0, then you can say the charge at A, minus E charge at A is in equilibrium. If it is in equilibrium, automatically charge minus E at B will also be equilibrium, because, is it clear? Because of symmetry, okay. Therefore, that gives you, okay, 1 by 4 pi epsilon naught into E squared by X squared, that is equal to 1 by 4 pi epsilon naught into, what is that? E into 4 here, because of this, divided by X squared. Okay, everything will go, okay. Therefore, you will be getting Q. Is it Q, no? It's QE now. Q. Therefore, QE into this. Therefore, you will be getting E that is equal to, this will go. Therefore, E that is equal to 4Q. And Q is equal to E by 4. Q is equal to E by 4. So, when the charge Q that is equal to E by 4, okay, for I want the system to be in equilibrium. Okay, therefore Q has to be kept exactly at the center of the line joining, what is it, both the electrons, right? Now, and what is the charge? E by 4. When Q is E by 4, automatically the whole system will be in equilibrium, everything. Okay, Q, a charge of E by 4 plus E by 4, when it is kept exactly at the center of the line joining A and B, then the whole system will be in equilibrium. Is it clear? Right. Next one, it is for practice. Two fixed point charges plus 4E, okay, and plus E units are separated by a distance A. Where should the third point charge be placed for it to be in equilibrium? Therefore, that charge has to be in equilibrium. Third charge has to be in equilibrium. It is not the system. Third charge has to be in equilibrium. So, how to do here? I will give you some, okay, because slightly, what is that, hint? Okay. Therefore, what is that here is 4E. It is plus 4E. And here is plus E. Okay. Therefore, now I want, where should the third charge, the distance of separation is A. Now diagram also I will give you. Okay. Okay. Therefore, third charge to be placed for it to be equilibrium. Third charge has to be placed so that the net force on the third charge due to plus 4e and plus e should be equal to 0. Therefore, where should be, if it is kept here, for example, where should it be kept? If it is kept here, okay, therefore, for example, you see, plus 4e repulsion, plus e also due to A and due to B. Everything it will be a repulsive force only. So, definitely there is no chance for it to be in equilibrium. So, no chance for this. Next one, if you keep it here, okay, I am trying it now. I am keeping it, keep that third charge here. If I am keeping it here, force on this due to A will be in this direction because what is that? Third point charge. Point charge I am keeping it as a positive charge plus Q. Okay, third point charge. And therefore it will be experiencing in this direction. Nothing, no, what is, where should a third point charge be placed? Therefore you have to take that for default positive, right? Therefore the charge is positive. Therefore when it is kept here, therefore force due to A will be in this direction and force due to B will also be in this direction. Therefore there is no chance, net force is non-zero. It will experience a force from, what is it, towards the right. Therefore there is no chance for it to be in equilibrium. So that is also not possible. We have to see that one. Now where should it be kept? If it is exactly in between A and B. In between A and B, exactly at the center like our previous problem, if it is kept, no chance. Why? Because here one charge is plus 4e, another charge is plus e. Plus 4e repulsion will be more. But plus e also it will be repelled, but what is that? The repulsion here due to the force of repulsion will be less when compared to plus 4e. Are you following? Because force on Q, that is a charge is Q, the third charge. Okay. Due to plus 4e will be definitely more when compared to plus e. Okay. So, what has to be done? Therefore, my charge, but I don't want any net force on Q. So, let me keep somewhere here so that it is far off from 4e, but it is very close to E. If I keep like this, then there is a chance. What is that? At this point, okay, it may experience therefore a force due to A, force on Q due to A and due to B. If you add, it will be equal to 0. So your charge has to be somewhere far off from 4E. Okay, and it should be on the line joining A and B. It should not be to the right of B. It should not be kept to the left of A. Why? That time it won't be in equilibrium. It will experience some force. I don't want Q to experience any force. Therefore, I have to keep it at this point. Let this point at O. Okay, that's it. Rest of the things, it is very simple that you can solve. You can solve, and what is the answer for that you give me? Okay, in the WhatsApp you give me. You just what is the answer for that? Okay.